We have the opportunity to do a little more thinking as we consider these theorems surrounding bisecting arcs and chords. And so again, if we've got a diameter or a radius of a circle, and if it's perpendicular to a chord, then it bisects the chord and its arc. Well, let's see here. And even though this is actually titled use a diameter, we're going to be using the radius. So it says in circle R, find TV. So we're trying to find the measure of the length of this chord, TV. And I've got a radius here, RU, let's say, from the center of the circle to the end point, RU, that's a radius. And it's bisecting that chord, and I know this because it's creating this right angle. And if I got one right angle, I've got four right angles since it's going to be perpendicular. So each of the angles there are perpendicular. Now, the length of that radius is 11. How do I know that? Well, from R to S is 6, and from S to U is 5. So that means that from R to U, it's got to be 6 plus 5, so that radius is 11. Now, if this is a right angle, and it is right here, let's say, I'm choosing this one, and if I extend a segment from the center of the circle R to this endpoint T, not a very good drawing, but there you go. Well, that's a radius. And in a circle, all the radius are going to be equal. So that means that that radius is going to be 11. And I've got a right triangle here. And I know that one leg is 6. And I need to find this leg, TS. And if I can find the length of TS right here, well, twice that amount is going to be the measure of TV. So I know directly across from the right angle is the hypotenuse, and that measure's got to be 11 because the radius is 11, and I know one of the legs is 6. Well, I can use a little bit of Pythagorean theorem, and I can find the measure of, let's call it TS, and then twice that amount is going to be TV. So, a little Pythagorean theorem action here. A squared plus b squared equals c squared, where c is the hypotenuse, and the hypotenuse is 11. So therefore, we can say that c squared plus, let's see, ts, what do we want to call it? Let's call that x. X squared, I'm going to substitute that for ts right now, equals 11 squared. Well, let's see, 6 squared is 36. Plus x squared, and 11 squared is 121. And we're going to subtract 36 from both sides, so that x squared is equal to, let's see, 36, 121 minus 36, 11 from 6 is 5, take away the 1, 11 from 3 is 8, is 85. And then if we take the square root of both sides, x is going to be equal to the square root of 85. And let's say that we're going to say that, let me put up here, x then is equal to segment TS. And since this radius is perpendicular to the chord TV, that means it bisects that chord. And we've just found what half of that value is. And so then TV is going to equal 2 times TS, and we just determined that TS is equal to the square root of 85. And then we're asked to round our answer to the nearest hundredth. So let's see, calculator please. We got 2 times the square root of 85. 18.4391 is what my calculator says. I'm supposed to round that to the nearest hundredth. And so then it is approximately equal to 18.44 units. There's sometimes that I actually really love geometry because you get to think, and it forces you to think. And thinking is a good thing. Well, provided you got a good basis for what you think.